Okay, and welcome to the final part of our little series on animation. This is going to be our final thing for animation in SVG. My plan is for the rest of the course to switch over to some easier to use JavaScript libraries rather than animation. Okay, but just to give you an idea about the types of things that you would actually have to be involved with if you wanted to build up something really quite large. Okay, so on the screen here, you'll see that I've got a black square, a green square, and a red square. Now you might say, okay, what on earth is all of this stuff? Well, you can imagine that this is a robot. Like normally you'd have a head up here at the top, you'd have an arm on the left-hand side and a lower part of the arm, and you might have a couple of segments with the legs. Now, the reason why I want to include this is because if you take a look at the robot arm, you'll see the robot arm is actually comprised of two separate joints. Okay, so it's got the upper part of the arm and it's got the lower part of the arm. Now, I've also included something down here, these little sliders. Now, we haven't had a chance to talk about sliders yet, but these things are known as range types. So it's input and type is not checkbox, it's range. Okay, it's not a drop down, it's a range. Okay, and what you can do with this, like if you take a look at the upper, or say we'll start with the lower part of the arm and I'll start making some adjustments to it. So this should be the red part. So you can see what I can do here is you can move this back and forth. I've got limits. I mean, that looks kind of painful already, but okay, it looks like this can get as far as here. Okay, and that happens to be pivoting upon this particular area right here. Okay, but now the interesting thing is the pivot point for this depends not only on just some particular value, but it also depends on the actual arm value itself, like this corner of the green part, which is the upper arm. So what I've done here is I've actually got a couple of things, a couple of sliders that allows me to control these things independently of each other. But of course, as you start to move things, it if you start to move the upper part of the arm, it moves both the upper part of the arm as well as the forearm as well. So you can get some very strange and funny looking animations, like maybe somebody running, jogging, etc., etc. You can imagine, especially if we had like a couple of extra things, including things like some legs going on. Okay, so how am I solving this type of thing? Okay, it turns out it's not as difficult as you might think. Okay, over here my robot.html file, there's nothing funny going on. This is all the usual stuff. Here are the input sliders. I called it a RUA slider for right upper arm and a right lower arm slider. And all I'm doing is I'm calling this function called update upper right arm, update lower right arm, whenever any of these values change. Okay, so let's take a look at the actual thing. Okay, over here, this is the same as what I did in the previous exercise. I've got a robot area, I'm setting up an SVG, and I'm setting up a constructor. Okay, so see what I've done here. First of all, I've got this thing called the body, which is simply a rectangle 100 by 150. But notice so I've got this thing called body, but right underneath it, I've created this thing called robot element, which is known as a group. So what is a group? Well, a group is simply a bunch of SVG elements that go together. So the idea is that as you apply a transformation to a group, it applies to everything inside. Now, I'm not actually doing anything with the robot element, but you'll see what I've done here is I've created this upper right arm and I made it green. So along with some dimensions, I cheated a little bit and chained a couple things together, and then I called something the right arm, and I added the upper right arm to this particular group. I also made a lower right arm. Okay, so you got a lower right arm, that's the red part. I moved it into the right location and I've added this also to the right arm. So you'll see now on this line right here, I've added the upper right arm and I've also added the lower right arm both to the right arm groups. Okay, and that's kind of the important thing, because now the idea is if I start adjusting the right arm, it will end up adjusting both the upper right arm and the lower right arm, because you'd end up applying both. Now, very simple. All that I've done down here in my upper right arm or lower right arm updaters is I'm calling these Mr. Robot, and I'm making some adjustments, and I'm setting the transformation matrix. Okay, so what I've done here, you can see I was doing a little bit of debugging. I left it in by modifying the upper part of the arm, I just modify the entire arm. And what I do is I apply a rotation for the current amount without any types of translation applied to a particular origin, which happens to be the point of rotation. The lower right arm, I literally just go to the lower right arm and I apply rotation to this particular part as well. And again, I try to get the location so that it actually makes some sense. Okay, so I get about moving about the correct pivot point. But of course, what will happen is that lower pivot point actually depends on where the value of the upper part happens to be. Okay, so this is just to give you an idea about how you would actually connect things together in terms of relative grouping. So you can imagine a really large system would work exactly this way. In fact, this is exactly the way how any of those 3D first-person shooter games actually work. If you see a character running, what it is, it's probably a bunch of these things that have been put together. These are known as skeleton models, and the only thing that makes it a bit more interesting is they simply apply different textures or skins onto the actual thing. But the underlying bone structure is always based on these types of things where you're literally transforming and rotating things together in groups. So you can imagine even you could add an extra hand down here at the end, and you'd be able to also manipulate that in such a way that this could be controlled individually as well as it could be controlled by this part here. You would now have a bigger group, and it can also be controlled by this, and maybe it can even be controlled by the entire position of the robot. Okay, now if you want to try something fun with this, here's what I would suggest you try. Okay, look, there's a place where you could put a head. What can you do with the head? Well, probably not very much, but maybe you could tilt the head back and forth if you wanted to. New slider. You could add a left arm. You could also add a left leg and a right leg and position this thing around in lots of different funny looking shapes. You may find that sort of interesting. Again, it's not one of these things that you must absolutely do, but I certainly encourage you to put at least a little bit of effort into it and try to get, say, maybe the left arm to work as well. It's just two more sliders, and you can probably copy and paste most of the stuff that I've done here. Okay, yes, it can be very, very frustrating, especially these transformations, trying to find the exact origin. Trust me, I've had things where before I got the rotation completely correct, everything works fine. Suddenly you move things a little tiny bit and the arm completely disappears because it's probably rotated completely off the screen. So it can be a little bit frustrating, but definitely cool when you do get things to work. Okay, that's all that we're going to cover in terms of scalable vector graphics for this course and in terms of animation and so on. Okay, so what I'm going to do for tomorrow's exercise, I'm going to be back on with a small video, probably not a very long video tomorrow, maybe about 20 minutes tops. And what I'm going to be doing is I'm going to do a little bit of a review with some basic programming in terms of polymorphism. So what I'm talking about are things that we did with the parking lot, where we had the different types of ID cards and things were going different ways. So I'm going to call that a review because that's the type of thing that's going to show up on the test. Okay, so I can guarantee you that on the test that you'll see on Thursday, there will not be any scalable vector graphics, so you don't need to worry about that. And likewise, there won't be any graphics appearing for the final exam either. I don't really have any intention on more graphics appearing even in the next few weeks. And if I do, it's going to be very, very simple graphics. It's simply to represent a couple small things. Okay. All right. So hopefully you have at least a little bit of fun here with some of the animation, especially the DVD logo. And if you can add a couple of joints to this robot to make it look a little bit more interesting, that'll be enough. At least you have a taste about the types of things that you would have to do in order to have animation and or graphics on a web page. If there's lots of really cool things, I will leave it here for you, but I'm going to warn you, this is very, very difficult. Some of the students saw this already. There's a really cool library called 3.js, and 3.js is a 3D library for dealing with lots of cool things, and they have lots of examples and so on. So let me see if I can find something. In fact, even this one right here is pretty decent. What it is, it's a 3D model that you can 3D world that you can go around. You can see how things actually move. There's lots of physics stuff built in. There's lots of other things as well. Like you can come in here and see how these things look. Yeah, you can rotate and spin things around. They're very, very cool. But guess what? It's going to be even more effort than, say, the two-dimensional things. But outside of the class, if you're looking for something really cool to try, you can give some of these things a shot. Okay, so that's all for today's video, and check back tomorrow for a review video on polymorphism.